right, Chingus. So I'm just gonna make a quick review video here on radiometric dating because it's the easier of the two. So remember, we're basically measuring how much radioactive material was in a fossil when it passed away, basically, and then how much is left over. The difference between those two tells us how old that fossil is because radioactive isotopes will break down at a constant rate. It does not change, and it's a super handy universal clock. So again, this image just kind of shows you what a half-life is. So half-lives are the amount of time for that specific unique element to break down from 100% parent material or radioactive material down into 50-50 radioactive material, parent material, and now 50% stable isotope or daughter, something that won't break down. There are four major types of radioactive parent materials we gave to you: carbon-14, potassium-40, uranium-238, and rubidium of some type. I keep forgetting the atomic number. We're going to work with, how about this question? Why not? All right, so I'm going to go through all three steps to calculate the age of a rock that we found that has rubidium-87. Okay, so this is the fourth kind of radioactive isotope we gave you. All right, so step one, find the total original amount of parent material. Remember, parent material is the radioactive stuff. How do you know? You look at what you have right now in your fossil or in your rock, and you take the radioactive stuff that's currently still radioactive and has not yet broken down, plus its daughter isotope, or the thing that it has broken down into. These two things combined tell you how much was originally in the rock or in the fossil when it passed away. So 7.5 plus 22.5 should come to basically 30 grams. Okay, so there's originally 30 grams of radioactive rubidium-87 in this fossil. Step two, make a half-life table. Now, I can't really draw a table super easily here. I'm going to try and do it like this with like really weird formatting. So remember that your half-life is the amount of time it takes to go from 100% parent material to 50-50 parent and daughter material. So we will start with, I always like to make an estimation of like 3 half-lives, and then I can adjust from there. Okay, so at 0 years or 0 half-lives has passed, I need to take the total amount of radioactive material that I had in my rock or isotope or fossil, and then I'm gonna divide in 2. Okay, and that will tell me, here I'm gonna make more space for myself. That will tell me how much parent material is left over after 1 half-life. 30 divided by 2 is 50 grams. 15 grams. Is that what we saw? No. You keep going in step 2. You keep dividing in 2, until you get to the observed amount of parent and or radioactive material. So we're going to do that again. Divide in 2. And here we go. We get to 7.5. And that was the amount that we were looking for. Okay. That's what we found in the fossil/rock. That's what how many half-lives it took to get down to that point. So now in step 3, you take the number of half-lives and then multiply it by the length of the half-life. That is unique to that element or isotope. In this case, it is really long, 49 million years. So I'm going to take 2 times 49, and that will give me 98 million years. And so this question is asking, how old is the rock? The rock is 98 million years old. Okay, that would be the correct answer. Sometimes your question might ask, how many half-lives does it take to get to this amount? And then you just simply answer from step 2. Okay, whatever it is you found. I hope that helps.